Hello, hello, hackers. How's it going? It was so great to see you all at the opening ceremony, and it was so much. It's so fun to see you all so excited about All in Hackathon. As I said, we have so much in store for you. But before I begin on what we are doing here for today, I would love to hear from you. So post a comment in the comment section. Show us some cheers. Show us some drum roll or some emojis on how you're feeling. I know I'm feeling really excited about this next particular session that's in line. We have some great speakers from Fidelity to talk to us about engineering best practices. We have Alan and Rajrajan backstage, and they're excited to share their tips with you. I'll be asking them to join us on stage and would love to give them a warm welcome. So post your messages in the comment section and let us give them a very warm MLH welcome. Hello, Alan. Hello, Rajrajan. How are you doing today?
Hello, thank you so much. Delighted to be here. Thanks for inviting us on. Yeah, thank you so much.
Hello everyone, very excited and happy to be part of the MLS hackathon. So yeah.
Definitely, and we are super excited. There were a lot of questions in Discord that I could see about getting started with hackathon projects and some of the best practices they can follow about and some tips that they can follow while building their products. And I think this session would be great for them to just get started with. Awesome. Let me bring on your slides and maybe we can get started. There you go.
Super. Thanks very much. As I said, delighted to be here. And my name's Alan Harney, and I work with Fidelity Investments. I'm a group chapter lead, or I head up one of our engineering within our cloud and platform engineering business unit inside Fidelity Investments. And I'm coming to you today live from Ireland. So as a group chapter lead in Fidelity, we're responsible for things like, engineering excellence, which we're going to talk a lot about here today. We're also responsible for things like hiring and growing exceptional talent, the talent that we have in Fidelity, but also the talent that we hire in, people like yourselves. Myself, I've been working in Fidelity Investments for the last 12 years. I really enjoy the variety that the role and position gives me. I get to work with external people like yourselves. I also get to work with all our internal business leaders and engineers across the globe. No 2 days around here are ever the same, which is fantastic. And today we're going to provide you an insight into some of the engineering practices that we practice here at Fidelity and that a lot of big enterprises would do as well.
I'll introduce myself. So my name is Rajarajan. So I've been with Fidelity for over 5 years now. So I'm based out of Dublin, Ireland, and myself and Alan, we're peers. We're part of the same team. We're responsible for building the technology platforms in Fidelity where the business apps run. So again, definitely excited to be part of this. So we're going to look at some of the engineering best practices. So feel free to ask any questions to us in the comments. We'll be more than happy to answer. I think let's get started, Alan.
Super. Thanks, Marianne. Okay, so over, I suppose, the next 20 or 30 minutes, and as Rajaran said, definitely keep your comments in. We'd love to go down in any route we want as we go along, but we have about 20 or 30 minutes. We're going to give you kind of a very brief insight or overview into what it would be like to work as an engineer in a large enterprise such as Fidelity. We're going to start very much with the why. Why do we need to do it? Why best practices, which is really important, I suppose, before we get going. Why it's important, I suppose, to implement them. After that, we're going to talk a little bit about, some of the components of the excellence. What are they? What are the engineering things that we concentrate on? We're going to go into, metrics and why this is important. So if you want to do something and you want to do it better, you have to be able to measure where you are today. So it's very important that we can measure engineering excellence so that we can see if we're improving over time. And we're going to talk about some of the metrics that are used in the industry and that we use to be able to measure that. You may or may not have come across things like, continuous delivery or CI/CD pipelines, or you may have heard it. We're going to talk a little bit high level about what they are, why they're used, and I suppose how they come into the story of engineering excellence as well. Just at a very high level. We can go in deeper if anybody wants to ask any questions on that. engineering and engineering best practices would be nothing without obviously building the right culture and the right types of teams. And we're going to talk a little bit about the culture at Fidelity. And I know Janelle talked about it earlier in the ceremony at the beginning, and we're going to talk a little bit more about that and what kind of culture our engineers have. We're going to finish out then talking a little bit about the future and what's happening in the AI space and how that all correlates with this as well. And as I said earlier, happy to make sure that you post any questions that you wanted all on the comments chat.
And Alan said, so we've sort of included things like CI/CD in the place because I know there are a lot of participants in this hackathon who are from schools and colleges. So just wanted to give a glimpse on things like that, because when you build things in hackathon, that's like very different from when you actually run it in production, when you run it at scale for a lot of customers. So a lot of these things comes into picture, right? So we're going to look at some of the things in the CI/CD space.
Yeah. Super. Okay, so getting into the why and why it is important. So, engineering excellence for software engineers is the same as for any type of engineering, but it really is about, the pursuit of being absolutely excellent at your craft. And it takes time and effort to become excellent at any craft, in particular engineering. I suppose if we talk about what it's made up of or what engineering excellence is, it's kind of made up of three things. Like it's made up of how we do things, how we operate, and how we function as a team. One way I really kind of, I suppose, of thinking about it is, and as engineers, we very much concentrate on the what tool to use, what language to use. Engineering excellence really concentrates in on the how instead of the what. How we're going to ensure that our code base stays clean as we scale and our amount of engineers. We had 5 engineers and we scaled to 100 engineers. How do we keep it clean? How do we, it changes a little bit. The what sometimes can change over time. You get new tools or you get new languages that you might use, but the how shouldn't change that much as we evolve over time. So it's a good way of kind of thinking of it over that. There are kind of 4 kind of basic pillars of engineering excellence. Kind of going to talk a little bit about today. Again, the why do we do it? And one of the whys is happiness. And it's not just, I suppose, 2 points there in terms of satisfying our customer needs, which is obviously really, really important. But it's also just important that as engineers, that we're happy that with the work that we're doing. That it's not repetitive, that it's interesting, that we're using tools and technologies that we're invested in, that we love to use. So it's really, really important that we deliver delight to our customers, but we also deliver delight in the way as engineers that we actually become better engineers and better at what we're doing due to the love of what we're actually at. So it's really, really important on that. Craftsmanship is very much at the heart of excellence. Like it's really about our skill sets and how well we build software. How much with thought we put up front into the kind of the design and the implementation, not just diving straight into the the implementation without first thinking a little bit about it. It's also about how we think about things like testing ahead of time. One thing we really need to talk about when we're writing code or developing software is how confident you would be that your work, once you put it in front of your peers or put it in front of other people, how it would stand up to scrutiny, ensuring that you're not cutting corners or things like that. And we'll talk a little bit later about code reviews and what that process looks like, but it's really, really important. What kind of tools and technologies, what stacks you're using, being very proud of the type of work that you're doing. From an effectiveness point of view, this is all to do with kind of problem solving and project management. And some aspects of that are, do you have the confidence to execute, on time and in budget? So it's really, really important that you understand what the work looks like, how you can identify how the technical aspects of it, any risks that there are to the work and being able to deliver it and being able to solve those in a timely manner. And be very effective in that. And of course, productivity, it's all about, are you spending more times on things that matter than things that don't? Are you able to make time to design, build, and test and how effectively you're able to actually zoom in on the most critical kind of issues at hand, troubleshooting bugs, and making sure things like, you're documenting your work so it's easily able to hand it off to somebody that wasn't maybe directly involved in it bit upfront before that.
I want to add like a couple of things, right? So when we talk about the why for the engineering best practices, I think one of the ways you can think about it is they form these solid foundations for you to build things in a secure and reliable manner. So in a company like Fidelity, where we have like a lot of innovative, the financial products. So when the users, customers, when they actually interact with these products, they actually entrust us with like a lot of sensitive data, right? So there's a lot of customer data, is involved, and it's like our responsibility to make sure the products that we build out are built in such a way that we sort of protect all those data, right? So it's like super important if you want to build a secure and reliable system. You need to have these things, and that becomes the foundational elements, right? So and one of the things that we do here in Fidelity is like we want to be able to respond to a lot of these macro things that's happening outside. So if there is like some sort of a change we want to roll out pretty quickly because of like some changes outside, we want to be in a position where we roll out things pretty quickly, but at the same time we have the confidence that when we roll this out, it's going to be secure and reliable, right? So all these things become like a foundational element for it.
Yeah, it's definitely super important. And I suppose that's a lot about the why, and some of the components we look at, we tend to kind of, I suppose, we have to look at different elements of what makes up that and how we actually dive into it. And again, going to give a kind of high level overview. These are some of the components, not all of them, of course. And, I talked a little bit about maintainability. When we write software and we deliver it, it's never a one and done, right? You have to build it to ensure that you can constantly keep it up to date and evolve it over time. So you need to make sure that you build mechanisms such as, and again, we talked about, automated testing or your pipelines to be able to deliver your code production. Having all that in place allows you to be able to maintain your code base and your applications and your software an awful lot easier and better. So it's definitely one thing to look at. In terms of observability, this is really important. You need to know things like, even when it's working normally and your software and your application is up and running, you need to know who's using it, how they're using it. And then when it's not working, you need to know why, or when it's not working, or if it's intermittently not working. So having observability, alerts, monitoring, dashboards around your service is really, really important. I don't need to talk too much about reliability. I think everything that we build needs to be available, and that's probably more apt now than it's ever been. If you think about any application that you have on your phone or any application that you use out in the industry, how important it is, and when it's not available, and how frustrating that is. So everything we build, building reliability into it has to be done from the design stages right through to ensure that things will always break, things will always change, and it's making sure that you have mechanisms in place to be able to deal with that. And again, going back to our continuous improvement, continuous deployment pipelines, one part of that is, if you're doing changes, making sure how you don't allow your application to go down during those changes, how to keep it up and change it at the same time, which is very important. From a security perspective, you need to make sure, obviously, keeping it secure and being an fintech company is hugely important. Only given the right amount of privileges where they need to be, and implementing things like these privilege security, having your secrets hidden and dealing with that, storing them in vaults or password vaults or whatnot. Again, very, very important. Accessibility is really around making sure when you're building something that somebody else who doesn't or wasn't involved initially with it can easily understand it if they were to go and look at it. And that's the easiest way I can describe that. And we have a lot of that. We have teams that evolve or build, and applications that might go from one team to another, or new engineers that join. How easily can they look at a document, look at a design, look at a run book, to be able to understand that person's code? Even how you comment your code is so important when it comes to that. If they need to make a change to it, how confident are they going to be to it? So really, really important. And things, just finally, like on data storage, things like, how you do data replication or recovery. It's awfully important. And one thing I would say about all these aspects, like sometimes it can be very quick to build an application that solves the problem that you want, but to be able to implement all of these things on top of it actually slows you down initially from, you know, an application or service that you want to deploy to production. To have this baked in and thought about and done correctly does slow down initially, but allows you to move faster eventually further down the road.
And none of this, just to add, none of this should be like an afterthought, right? So things like observability, for example, you should actually think about those things right when you know, plan your design. So when you actually design a feature, when you think about like how you're going to roll it out, you should actually think about like how you're going to you know, set up the monitoring, you know, alerting, things like that. The code that you write, is it observable, right? So all these things should be part of code reviews. So it's very important that like before you roll out the feature, you should basically have a setup where you know that you know, we would proactively get alerts when, you know, things go wrong or when things are about to go wrong. And it shouldn't be the case where, let's say, the customer sort of complains and then you get to know, right, things are going wrong. So all these things should happen right from the early stages when you actually plan and design the features.
So we talked a little bit earlier about measuring excellence and defining excellence. And again, just to reiterate the same point, to be able to improve on something, you have to be able to measure and figure out where you are today so that you can also measure in the future to see have you improved. And this is one method of being able to do that. So these are called the DORA metrics, and the DORA metrics are, as I said, they're used to be able to measure the performance of DevOps teams, right? So teams are actually ranked from being either low performers or they're ranked to being, you know, elite performers. And it's a concept that was developed at Google, some 7-year project that they analyzed all these DevOps practices and capabilities, and they identified these 4 key metrics to be able to measure the performance of software teams. And the 4 metrics, which are in green and blue there. So you have deployment frequency, right? So as simple as how many times or the frequency of how successfully you are able to push software releases into production. You have things like lead time for changes. That's the difference between, I suppose, the first commit and the time that you actually deploy it to production, and how long that actually takes. The time to recovery. So the time to recovery is all about the time that, you know, again, failures are going to happen, interruptions are going to happen, but how long it actually takes you to be able to detect it, which is very important, and then recover. Because if you can't detect it, it may go unknown at some time, and being able to evaluate the time it takes to do that. And the failure rate. So as you're putting hot fixes in, or if you're making changes to your code base and you're deploying that out, how many times does that actually eventually lead to a failure within your system, and being able to measure the amount of those changes that you make that result in a failure or an outage or something breaking. So this gives you an idea of what I was talking about earlier between, you know, the difference between the low performers and the more elite performers. So deployment frequency, as I said, is as simple as, you know, some teams it's normal to do 1 deployment a week, but that's not the only option. The teams can have up to multiple different deployments. They could have 7 deployments in a day for some of the high performing teams. You know, some mobile application teams deploy once or twice a quarter. Some other SaaS solution teams deploy multiple times a day. So there is a huge difference between that. And it's a very easy thing to be able to measure. So you know, you can just read the amount of deployments that you have a day. And again, this is why I suppose I want to talk a little bit later about CI/CD pipelines. And this is one way to be able to gather that data from your CI/CD pipelines, how many times you're able to actually deploy. I talked about lead time, and if anybody's, I suppose, familiar with the lean concepts, you know, there's a concept of lead time and cycle time in all industries, and software development is no different. So lead time is very much, you know, how long it actually takes from the time that you've been asked to do a feature to the time that you satisfy that need. Okay. And the cycle time is actually how long from the time you actually start working with your team on that feature to the time that you actually have it in production. So there is a slight difference between those two. And it's very important to look at the lead time from the request right through to when it's going to be satisfied. And again, quite straightforward to be able to get that. If you again take the time that you have that commit to production away from the time that the request came in, you can easily work that out. As I said, with the time to recovery stuff, again, everything should be built with the idea that everything will eventually fail, right? And making sure that you have measures in place to be able to get back up and running really, really quickly, automate it if possible. And the recovery time on that, obviously, depending on what you built into it, companies have very short times today to be able to recover. We work with a lot of financial systems where there's very little to no tolerance of any sort of outage time. So that time to recover, once you know what it is, and if you know you can keep it very small, it actually allows you to feel more comfortable with actually doing more risk taking in terms of innovations and changes, because you know can recover very, very quickly. Whereas if that mean time to recover is very, very long, it does stifle that an awful lot. And the last one then, the change failure rate. Again, how many times do you have to roll back if we put in an update on software or a bug fix? How many instances are created because of that? If it was either a customer that got impacted because of a change we made, or we may have to roll back to a previous version of software that we deployed into production. So it's very much a measure of quality and stability within that. And over time, that does give you huge insight into how much you spend as a team on fixing bugs and delivering new code. And there can be lots of different reasons why you get kind of poor DORA metrics, right? And some of this we'll go into on the code reviews as well. But some reasons why you might have poor DORA metrics could be because you have very large code changes going in all at once. And having very poor quality written code, and that can lead to difficulty maintaining, or other people trying to solve your problems. Having some complex routes or complex solutions, sometimes really, really complex solutions, can be hard to untangle to actually figure out. Automation, I mentioned it multiple times there, but not having automation in place obviously leads to a lot of these going out. If you don't have automated testing or automated rollbacks, or the more automation you can have, the better it is for a lot of the timings on this. And of course, if you're able to do things like infrastructure changes, reusable infrastructure changes, or infrastructure as code changes versus manually deployed infrastructure, all of that leads to an awful lot better breakdown in terms of these metrics. Of course, there's some simple things that you can also look at in terms of this. So you don't need all of these fancy metrics to be able to have a look to see, you can use some very simple ones to be able to have a look yourself. Such as, how long it's taken for your pull request to be able to get merged, or, how long your feature branches are around for. So you don't have to go to the depth of the DORA metrics. There are other simple methods that you can kind of have a look at for some of those. So I talked a few times and alluded to code reviews, and this is really important. And there's lots of good reasons for doing this. And when you do the code reviews, I suppose is really, really important. And I heard it called out earlier that you're all going to be working as teams or groups, and as a team or a group working together, you're doing swarming sessions. That is part and parcel of that. Should be reviewing and looking at each other's code and coming together. But if somebody that you want part to actually do your code review, a good time to be able to do that would be after making your initial kind of pull request. And that's probably a good time if somebody that wasn't involved during your swarming session to be able to kind of come in as part of that. The real reason you need to be able to do code reviews is to ensure that the overall health of your code base, if you have a very large code base, to be able to ensure that it's improving over time. And also to be able to ensure that the problem that was supposed to be solved, it does actually solve it, which is to ensure that it actually does as it was designed to do. anybody can get involved in the actual the review. You don't need to be somebody that needs to rubber stamp it or approve it. Anybody can review somebody else's code, right? It's an absolutely fantastic way. It's something that we encourage here in Fidelity. It's a fantastic way to learn, fantastic way to be able to collaborate. We work with lots of different distributed teams, and we've reviewers that may be across multiple different regions. And where, in a situation like that, or a new person joining a team, that they'll have an opportunity to be able to look at how other people develop and learn from that as well. And they don't have to approve it. As I said, they can just leave a message, or just to say, it all looks good to me, or, if they don't feel that they're at a stage where they're qualified to be able to approve it. So the who should review the code is definitely different from who should approve it. So if I go into who should approve the code, then, the approvers really should be the experts who understand the application or the domain of that particular application. It should never be one person, of course. It should definitely be more than one person. At least two people should be part of those approvers, and they should be part of the squad or the team. As I said, they have to have that innate domain knowledge of the application, and they should obviously, I suppose, when we think about what they should actually be looking for, or when they should actually be doing it, and some of the best practices around that. Code reviews, we always say, should be prioritized. They, before they come in and start looking at any new tasks or a new piece of work, code reviews should always be prioritized. Otherwise, you're going to sit there, and we would have an expectation here that they are done within one business day. Alternatively, in the mornings or in the evenings, whenever it suits people best, or teams can review when's a good time to be able to do that. We talked about the size of these pull requests earlier, and one thing that we would always say is that they should be kept small enough that they can be reviewed in a small amount of time. So one thing that we saw is, if you have thousands of lines of code that somebody needs to review, it can be an awful task and really difficult for that person to try and review it and understand it. But if you're making them smaller chunks with a singular purpose in that review, it makes it much easier for that review to actually happen. Again, talking about, are they solving the problem that's there? Are they ensuring that they're testing it correctly? Definitely is something that the reviewer needs to see, and being able to understand the code easily. That's not overly complex. Making sure that it actually, we have, if they have a particular problem that they need to solve, that it's actually doing it. And there's a cultural aspect to this, and I'll go more into the culture later. But code reviews aren't there to, you're not reviewing the person, you're reviewing the code, and I think that's a really important differentiator. It isn't a personal thing, and it is somewhere to learn, and that may seem simple, but it's definitely something needs to be understood across the team, or the people that are working on it. Like, our entire squads are responsible for the head of the code. It's not responsible for one person, so there should be no finger pointing or that. And there's no such thing as perfect. I think that's probably there's only better, not perfect, right? The pursuit of perfectness is definitely something that's never going to be achieved. And I think in the way people leave their feedback is very important. So it is feedback at the end of the day. Trying not to be critical in how they leave it, and we would all encourage people to also leave positive things as part of their code reviews. So it's, sometimes it can be just on what needs to be improved. We would also say, oh, that's a good job, nice way of solving the problem. Give praise along with the constructive feedback, I think, is a really good way of doing that. It's a process. Code is always going to need to be reviewed. It should be written with the knowledge that it's going to be reviewed. It doesn't matter where errors come from or when they were introduced or who has it there. It's not a blame game. It is really about catching that as a collective team. And it's very important to be able to do that the whole way along.
I want to add a couple of points here. So the first one, which is probably often overlooked, is whenever you do the code review, you also sort of have to make sure that the relevant documentation is updated. So whenever there is a code review, there is like a piece of code that gets changed, you probably have to look at like what is the impact on that on the end user experience, and does that mean that we have to change the documentation? So I think one of the best practices is to make sure you incorporate this into the PR review process / code review process, where whenever there's a change happens, the documentation change actually goes hand in hand. Few more things which I want to call out. It could be an interesting insight. So there's a lot of innovation happening in this space, with AI, even without AI. So the first thing I want to call out is, Alan previously was mentioning about the infrastructure as a code, right? So the community is actually going, I think they very well comfortably have gone to a space where anytime when we create an infrastructure, it's basically through code like Terraform, and a lot of these other tools are there. So there are a lot of tooling that is coming into place that basically sort of adds some insights around cost. For example, let's say you write a piece of code, you submit it for review. There is this tool that will actually come in and say that, you know what, this has so and so impact on the cost, right? If you're spinning up, let's say, a lot more EC2 instances or like servers, this is the kind of cost, right? So that aspect also is coming into picture, because we are sort of entering into a space where we want to be like really, really efficient, right? So this is again keeping AI aside. There are a lot of toolings like this coming into picture, right? Again, same for security. And on even on the AI side, we are seeing that there are a lot of tooling that is coming into picture where it sort of helps with the code review. So as soon as the PR is created, there is a bot that would actually come in, and it will basically look at a lot of things around, for example, security, like optimizations, and obviously cost. They're also trying to do a lot of things around cost. So I think this space is definitely having a lot of innovation and something to look out for. Um, just wanted to mention those points.
Cheers. Thanks. And I know we talked a few times now. I've talked about these pipelines and these CI/CD flows and how we deploy code to production. And I'm definitely not going to step through every element of this diagram whatsoever, but just to give you a kind of an idea about a kind of a typical CI/CD flow, and just to talk a little bit about what is CI/CD, what is it, what does it mean, and it's quite straightforward. All of these steps basically are automated, and continuous integration is really all about merging your changes into the main branch as often as possible and having them tested as you're doing it at scale, being able to run automated tests against those builds and having them in there. And that's all the continuous integration is. And it puts a huge amount of emphasis on having that testing automation in place, to be able to check to make sure that your application is not broken whenever new commits are put into the main branch. Sorry, yeah.
Just quick note around this. So some of the best practices around this is in the recent years, what we have seen is the community is going down the route of abstracting away a lot of these tools from the developers. Where, for example, I don't have to, as a developer, I don't have to deal with the tool that does these things directly. So I would actually go to my Git repo and then sort of describe my requirements, like, so something we call it as Git ops. You can definitely look up Git ops. So the idea here is, as a developer, when you finish writing your code, when you want to roll out your changes, you go to another repo where there's some sort of a format that you follow, maybe through JSON, YAML, whatever. So it's just another file where you go and describe, stating that, like, my application needs to be exposed at so and so URL, and it needs to scale using these metrics, for example, right? So by default, run 2 instances, but let's say if this particular metric goes to 60%, 70%, then you scale up to this. So all these things you sort of describe somewhere, and there is the system that works behind the scenes to make that happen for you. So one of the advantage with this approach is, whenever there are a lot of changes happening around, like, a lot of these toolings. So a lot of things come and go. There are improvements. So whenever you go down this route of, like, as a developer, you just like worry about describing what you want and not the tool. It's very easy for the operations team, for example, to make changes behind the scenes, because from your perspective, what you have described as a requirement, that doesn't change. It's just the tooling changes behind the scenes. So it makes it a lot more easier / smoother for the overall operations, because they can change things behind the scenes. At the same time, what you have described doesn't change, right? So there are a lot of these things happening as well. Just wanted to mention that could be an insight.
So you're dead right. And in terms of, I suppose, we have, continuous deployment. Like the main thing we want to get to is that we have automation, that we can abstract some of this away from the, we talked earlier about where the engineers want to be spending their time. That's really on developing solutions and being able to get them to production. So the ideal state is to have continuous deployment where all you worry about is actually getting your merged into main, getting your pull request opened, and once it's merged in, that it goes to production automatically in the background, and that's really where we want to get to. And it, that's not just about throwing it into production hoping for the best. It's about putting it through a pipeline that had, like the one that's displayed here, that has, it's released, it's customer available, it's been tested, that it's not going to fail when it goes in there. It's not going to have any adverse effect, or if it does fail, it automatically resolves that, or reverts that change there. And that continuous deployment it's an excellent way to be able to accelerate the whole feedback loop with your customers and be able to have those multiple multi-day releases. And it does allow our developers and engineers then to concentrate on the software building, versus having to actually get it into production or through all the environments, or put it onto multiple different servers, or whatever involved in that whole automated process. I talked a little bit earlier about culture, and I know Janelle talked earlier in the opening speech about culture as well. And I do want to talk about, we've talked about DevOps teams, and we work in Fidelity very much as within the agile fashion for many years now. And we continue to build the DevOps culture within our teams, and we work as, we try to work as part of the Spotify model, which means that we have squads or teams of 12 people or less, and those teams are generally distributed and can be between 2 or 3 different regions. So a lot of what we talked about, it involves people from different time zones, different regions, being able to do that. And each of our teams have full autonomy to be able to, build their own software, but they also own the whole life cycle from end to end. And I think that's really important, that it's not just build it and forget about it. It's they're responsible for building it and running it, deploying it, and supporting it. And I think it's really important for anybody that's running or creating software or engineering to actually have that kind of mindset, that you're thinking about the testing, you're thinking about the operations over time, and the maintainability over time. And that really is a cultural thing that needs to be done. And it's very important that the understanding is there, that I talked about failures earlier, but failures aren't negative things. They really are learning opportunities. The whole idea is to fail fast and evolve. And that's innovation at its very best. We've lots of different examples of where that happens, and that's something that we really do encourage. The last thing we'll talk about culture is, this space, and we work in cloud, and the cloud space itself it really is emerging, really, it's quickly evolving, and trying to keep up pace with that is becoming more and more difficult. So it's really important that you have a learning culture, making sure that you take time to be able to keep up to date with everything that's going on. And I'm going to talk, I'm kind of going to leave it there a little bit and pass it over to Raja. I was going to talk a little bit about where we're kind of going, next steps, I suppose, in the future, and some of the tools and technologies that we're going to look at, and that we're looking at in Fidelity as well.
Yeah, so we wanted to close this off with a couple of slides on, again, this is not more on the best practices because this is still early, but we want to talk a little bit about how we are actually embracing AI in the software engineering space, right? So I think the last few years, all of us have seen a very visible impact by AI in many spaces, but especially in 2023, I think it's a special year where a lot of these LLMs like ChatGPT and things like that have changed a lot of things. So I think from a software engineering standpoint, there's a lot of things that's going to change in the upcoming years. The first one is an obvious one, which is the coding assistance. I'm pretty sure all of you who are actually participating in this hackathon are probably using some sort of an LLM out there. If not, you should definitely do that. So I think from a fidelity standpoint, we've started rolling out a lot of things around the space. And when we talk about the coding assistant, obviously the GitHub Copilot, for example, is a pretty famous one. So I think the idea here is to augment our developers with these assistants, where the developers sort of become like a lot more productive. And whenever you become productive, you're able to deliver, as in you're able to roll out a lot of features. And as a developer, when you think about it, if you're able to do more and more and deliver a lot of features with very less friction, that basically leads to a lot of developer happiness, right? So when the developer is happy, obviously that leads to better product, that leads to happy customers, right? So I think some of the things which I wanted to touch upon is slight nuances, but I think it's important for you all to know, right? So whenever you sort of work with an LLM outside, like let's say ChatGPT or Claude, to generate a piece of code, it's very different from working with an coding assistant, like for example Copilot, right? So the things are subtle, but it's important. So one of the things you can actually do is to set up guardrails, especially when you're working in enterprises. There are a lot of things that you need to take care of. We mentioned security and things like that a few times here, right? So whenever you work with like the coding assistant, you can actually set up guardrails in such a way that one example is you can actually set up the guardrail in such a way that, hey, the piece of code that you generate, make sure it's not something that's out there in the internet, right? So those things actually become important when you operate in an enterprise space. So you can do a lot more things. So building these guardrails around these coding assistants, that's something that is like super important. So one of the things that we anticipate will be the first set of things that will change is the coding assistants will help a lot and lot around the testing part of it, right? So in terms of writing test cases, and also doing it in such a way that it's a lot more secure. And I also want to mention one more thing around what we are seeing, where there are a lot of these specialized fine-tuned models coming up for very special sort of things. For example, let's say if you want to build SQL queries, right? So we're actually seeing that there's very specialized, we call it as SLM now, right? Small language models that are coming out there, which basically, are specialized in, let's say, generating the SQL code and things like that. And just to give a glimpse of where we are actually moving forward, apart from the coding assistance. So one of the things that we expect to see is, again, we touched upon this in the code reviews. So bots actually coming in, agents actually coming in and sort of working with you in terms of doing the code review. And also we're sort of trying to use this to create, for example, the chat experiences for the product documentations, right? So as a developer, when you roll out a product, there is a documentation out there, but how do you sort of incorporate features in such a way that the users can sort of interact with the documentation, rather than having to go through the documentation in detail? So that is something that we are seeing that it's actually coming up. Again, a lot of these things that I've mentioned, if you look at it, it's geared more and more towards making sure the developers spend a lot more time on bringing the actual or working on delivering value, which basically means that you have a lot of room for them to be like creative, build a lot of things. And a lot of the heavy lifting around churning a lot of this code, we do it along with the coding assistants, right? So again, I think this is a space to watch out for. There are a lot of things coming in the space. Yeah, just wanted to touch upon few things around the space. And feel free to post any questions in the comments. We'll be happy to help answering those.
Awesome. Thank you so much for sharing that. It was great to see that there are like so many best engineering practices. And I feel like I've been working in this industry for 2 years now, and even then there was so many new things that I could learn about some of the best practices that we could follow while building products. So while folks are posting in their questions, I do have one question of my own. I know that you mentioned about and touch based upon AI pair programming and stuff, and one thing that I've seen in a lot of organizations that is being followed is like actual pair programmings with developers, other developers in the team, that can help reduce ramp up time and can help learn more engineering best practices that the team follows. Do you have some tips or suggestions on a beginner joining a team or someone new joining a team? How can such practices be followed to reduce developer ramp up time?
Yeah, I think as I can mention, and again, feel free to add, Alan. So I think one of the things that is very important is every team sort of establishes some sort of a solid onboarding process. So, for example, in our case, we try to make sure there are mentors assigned right when somebody joins. So I think that is like one good way to start. And when we talk about the AI pair programming, I think the change is already there, but at the same time, it doesn't mean that you cannot actually pair program with another developer, right? So you can actually do a combination of both. When you actually write the first set, you would do it along with AI, but then when you actually, as a next step, you can actually do it along with one of your colleagues as well, right? So we can do that, but I think establishing a mentor and having like a solid onboarding process, that's like important. And I think documentation. I think that is one space where if you really want like a very fast ramp up, you need to invest right from day one as a team, that you need to invest in having, making sure you have like proper documentation and things like that. So that might sound like a simple thing, but that actually goes a long way. Yeah, just want to add that.
Yeah, I'd also add to even having, I think you kind of alluded to it there, but even for people new joiners to the team, leaving kind of the small changes, having kind of, first time kind of changes that people can get used to the code base, but also the code reviews that we talked about earlier, having a look at what others are doing is, it's a fantastic way to learn. That's why the code review process isn't all about just reviewing and approving it. It can be used as a learning mechanism, especially if it's kept, as I kind of talked about earlier, if they're kept to kind of small feature type changes, it can be a great way to be able to see how they're implemented by either more senior people or people with more experience within that space.
Yeah, and a couple of things which I think it's interesting. So I wanted to mention. So the shift we are seeing here is, previously you would sort of write code and you would then go about like commenting, right? So um, in this case, if the more and more you work with the coding assistants, your prompts are becoming the comments, right? So from day one, you're having a proper code base where there is like comments, and that's your prompt, and based on that, you're getting the code. So it becomes a lot more easier for someone to actually come in and sort of read. But on top of that, one of the trends that I'm pretty sure all of us are probably already doing it. Whenever you work with a new code base, it's very easy to understand right now. For example, per my personal experiences, like very recently when I was looking at the LangChain code, it was a lot more easier for me to look at the LangChain code, where I was able to um, select a particular section of code and ask questions to it. Without AI involved, it would have taken, let's say, days for me to understand the code base. Now it is actually like minutes, right? So these changes are something that's like very interesting as well. So you sort of, even for understanding the code, you're actually using AI, and that's going to speed up a lot of these things. And things like onboarding, right? It's going to impact the onboarding. So that's like a big shift that we have seen.
Definitely, yeah. And it's interesting to see, like, with a lot of people, folks who are hackers who are building projects this weekend, it would be great if they can try out these tools as well. And at the same time, as you mentioned about code reviews and documentation, I think it's important. It's an important aspect to consider while building your projects, hackathon projects this weekend as well. With good documentation, they can actually take it forward, and even after the hackathon, they can progress on it. They can open source, create it as an open source project where they can get contributions from other hackers and follow the code review process that you recommended. So yeah, thank you so much for sharing those tips. It was great. I think we have one question that I see here, which is, are we going to build a product for Fidelity? I mean, I think they mean in reference of this hackathon. Are they going to bring products specific for uh, like Fidelity, finance, or anything else? Uh, yeah, I think I have three categories that I can share. Is there something that you would like to add to this?
No, I think we do have a category where I think it's for the financial space, right? So again, since you mentioned open source few time back, so like whatever you build, if it's on the financial space, obviously if you can actually make it as an open source project, in Fidelity we sort of invest a lot in open source. So we're actually in the journey of being like an open source first company, right? So if you're able to build something and sort of make it as an open source, so we can collaborate on the open source front as well, right? So just want to mention that.
Definitely, yes. Feel free to check out DevPost. There are more links and information on what our categories are for this weekend. So if you want ideas on what to build, how to go about it, they're definitely great resources to get started with. Again, if you have more questions, feel free to post them in on Discord and we can take those up there. Okay, awesome. All right. I do have one other question. I think we touched on it a little bit in the presentation, but I wanted to know your opinion on cleaning up technical debt. With a lot of these projects, there is a point where there's a lot of technical debt in these projects, and moving forward, it gets difficult to develop further. And so it's important to have a good balance between introducing new features and cleaning up technical debt. And so, what are your thoughts on that?
So maybe I'll start. I always think the best teams sort of excel in sort of figuring out the balance between that. I think the first one is to make sure you have a process in place that sort of tracks it, right? So, for example, if you are using um, some sort of a tool where you track your issues or stories and things like that, so make sure you have a category in place. And you sort of empower your developers to sort of make sure that they tag some, let's say they identify something as like tech debt, and but for whatever business reason they're not able to get to it, make sure they sort of tag it and you sort of keep a track of it, right? So, and that would basically tell you, where you are in terms of your tech debt, and making sure that balance is like, right. I think that's very important. So tracking that is like super important. Have some sort of a mechanism. There are a lot of ways to do that, but you need to have at least one sort of mechanism to track that. Yeah, but that's a very good question. Thanks for bringing it up.
I think it's important just to focus that I suppose every team has it and they do need to have a plan of how they tackle it. I think that's, you can't ignore it. And as much as it's be nice to ignore it and put it in the background and just concentrate on the nice feature developments the whole time, it does need to, I suppose, to have a sliver across every single time. You need to be constantly kind of trying to keep it at bay or to reduce it. And I think that's an important bit. And it's about going forward, reducing how much you're introducing. So tackling it going forward and then looking back and trying to bring that down as well. So I think it's just important to have a plan and a mindset around that. And whether that's that you spend 20% of your time or 50% of your time on technical debt, I think that's based on your own team that you're working in or the amount of technical debt that you may be carrying.
And don't use it as a substitute for bad code, right? It's not actually bad code. If you think about it, almost always a proper tech debt means you sort of came up with a solution based on the situation, and the situation has changed, and you have to make a solution. But there are some business commitments, client commitments. Because of that, you're not able to get to it, right? So that's tech debt and not actually bad code. But there's a lot of times we see that it's actually a bad code, which means you have to fix it. So you cannot actually take it forward, right? So I think that differentiation is important when you look at tech debt.
Definitely. Yeah. Awesome. Thank you so much for sharing these best practices, because I think along with the tools, it's important to have the mindset, as you said, in order to make sure that we are progressing and approaching technical solutions in the right way. But yeah, it seems like we are almost at time at the end of the presentation. Thank you so much, Alan and Rajan, for taking time out and sharing your tips with us. It was great to hear from you.
Yeah, and there's one question: share a GitHub link for Fidelity. So you should be able to, or maybe I can quickly. So you can go to github.com/Fidelity. So you will be able to see a lot of our open source projects. So feel free to sort of contribute, get engaged there. So just go to github.com/Fidelity. Just wanted to answer that. I just saw that.
Of course, yes. I also posted the link for your reference in the comment section, so you can visit this link as well. Cool. Awesome. All right. Thank you so much. Thank you so much for taking the final question and taking time out to share your tips with us. Thank you.
Thank you so much. Best of luck to everybody at the hackathon.
Best of luck.
All right.